respect to t. Okay, so with this one, you just have to remember the formula for the integral of log base a. Well, in this case, you can use u, but we'll just go ahead and use t. With respect to t, remember that's t, well, usually u, times the natural log of t. That should be the absolute value. Yep, absolute value of t. Well, for the most part, it's usually positive, but they kind of use that as a formality to make it absolute value. Minus 1 over natural log of a. Okay, so really here, all we have to do is just factor out our 11 times the integral of log base 14 of t with respect to t. And we know our a is equal to 14. And our u is t, which we already plugged that in. So that's going to equal, I'll put it underneath so I'm not squeezing everything in there. Okay, so that's going to equal 11 times t times natural log of t. Minus 1 all over natural log of 14 plus c. Okay. So if you want natural log of 14 as a constant, so you can factor that out.
So we're not doing any u's in this one? We're not replacing it with u at all?
Nope, because that's just a t. Oh, there it is. So that being just a t, we can just make our u equal t.
Okay, so if it was something else, then you would have to.
Oh yeah, if you had like 11t times log t squared. But from all the, I kind of went through the homework, most of the ones I saw were just t's and x's, so.
So is anything there technically a constant? Like it could be, I think you just said this, but 11t divided by natural log of 14.
And really the only constants are the 11 and the natural log of 14.
Oh, the
Yep.
t isn't?
Yep, the t's are actual variables.
Okay.
So pretty much the only time you ever use u is when there's like a sequence of things, not just one letter. So like if it was like x squared plus 6, you would place the whole thing right with u.
Yep, exactly. So if you had x squared plus 6 in here, then that means somewhere out here would have to be an x value. Because remember, when you get the derivative of that, it would be 2x. So if there's no x out here, then you can't use that method. All right, so you have 11 over natural log of 14 times t natural log of t minus 1. You can put the t up there if you want to and just multiply the whole thing by natural log of t minus 1. Or however way you want to set it up, as long as it kind of reads the same thing.
And again, those are absolute values, right?
Yeah, like I said, it's more of a technicality. Some books use the absolute value, some don't. The ones that don't usually don't have problems where the t would be negative.
My question would be, is on the homework, are they expecting us to put absolute value signs?
I don't think so. I think in this book, they just use a parentheses.
When you put it in, it could be right, but if you don't use one or what they're looking for, then...
Yeah, I know they're really picky, but yeah, they just want the absolute value. I mean, not the parentheses. All right. All right, so we'll do one more of these, and then we'll move up to the ones that's a little bit different.
Are you doing substitution?
Yeah. Okay, so we have the integral of -3 log base 3 of x with respect to x. And this one's the same formula, just different variable.
Okay, so this, you solve the same exact way.
Yep, the exact same way.
So
So you have log base a of x with respect to x is equal to x times natural log of x minus 1 over natural log of a plus c. So this one, once you factor out the negative 3, log base 3 of x with respect to x, where you know your a is equal to 3. That's going to give you negative 3 times x, natural log of x minus 1 over natural log of 3 plus c. Or just negative 3x over natural log of 3 times natural log of x minus 1. Or if you wanted to put the natural log of x minus 1 up top, you could do that also. Right. So our next example is if you have the integral of 9 over t minus 5 with respect to t. And this one's usually handy if you have a constant in your numerator and a non-constant in your denominator. Okay. So if we bring our 9 out to the front, you have the 9 times 1 over t minus 5 with respect to t. Okay. Now the method we're trying to, or the goal rather, is that integral of du over u equals natural log of the absolute value of u plus c. Okay. So here, what if we let u equal t minus 5?
yeah, I see, because the derivative is.
Yep, the derivative of that will be just 1, or dt. So derivative of u is equal to 1 dt, or just dt. Okay, so if we rewrote this one, 9 times the integral, we just bring our dt up to the top. dt over t minus 5. Then we can rewrite it as 9 times du, or the integral of du, over u. Okay, so that's going to be 9 times the integral of du over u is natural log of absolute value of u plus c. All we have to do now is replace our u. So you have 9 times the natural log of the absolute value of t minus 5 plus c. All right. Any questions on that one? All right. So the next one's the same idea, but it's a little trickier. Anyone's still writing? All right. So let's say if we have the integral of 9t squared plus 16t to the fifth divided by 9t to the third plus 8t to the sixth with respect to t. Okay. Like I said, this one has the same general idea, so we're going to let our denominator equal u. Because remember, we want to have the integral of du over u, so the natural log of u plus c. That's our goal. Okay. So if we let u equal our denominator, 9t to the third plus 8t to the sixth, then our du, go ahead and circle that, well, square it. Our du is going to equal 27t squared plus 48t to the fifth.
So would you do like bring 1/3 out?
You're on the right track, not 1/3, but we're going to factor out 3.
That's why
Yeah.
I'm at 30.
Oh, forgot my dt. Okay, so if we factor out 3,
We would get that 9t squared.
yep, so that gives us our du equals 3 times 9t squared plus 16t to the fifth with respect to t. So if we divide both sides by 3, our du over 3 is 9t squared plus 16t to the fifth with respect to t. So it's like I said, it's a little different, but it's kind of the same. It's a little bit of math trickery going on. All right, so our dt, we can go ahead and bring that up to the top just so it matches up. You don't have to do that. So you have the integral of 9t squared plus 16t to the fifth with respect to t over 9t to the third plus 8t to the sixth. Okay, so this would just become our du over 3, or the integral of du over 3 divided by, make that a little bit bigger, that, which is just our u. Or you can bring that up some. So really this is just 1/3 times du, so we can bring our 1/3 out.
See, I skipped that part. I found the 1/3 out, and that's how I got the 1/3 in the front.
Yeah,
Yeah.
you could have just did that. Which is our du over u. Okay, so you have 1/3 du over u is natural log of the absolute value of u plus c. All we have to do now is just replace our u. So we have 1/3. Move that over a little bit. Okay, so 1/3 natural log of the absolute value of 9t to the third plus 8t to the sixth plus c. Uh-oh. All right, so any questions on that one?
Hey, can you just do it one more for me?
Actually, we do have one more, and this one looks like this one, but it's you'll see. I know it's kind of hard to explain it.
Excuse me, before you
Mhm.
go up a little bit.
Oh, sure.
I don't know if I missed Yeah.
Oh, no problem. Uh-oh. Okay, so this example, see the integral of 30t plus 54t to the third divided by 10t squared plus 9t to the fourth with respect to t. Okay, so we have the same goal. We want to make it natural log of u plus c somehow. So we'll make that our goal. The integral of du over u equals natural log of u plus c. Okay, which means we have to make our denominator equal u. So we'll let u equals 10t squared plus 9t to the fourth. Okay, so that means our du is going to equal 20t plus 36t to the third. Okay. Now, you're not really factoring out anything to turn that magically into 30t plus 54t to the third. You have the t and t to the third, that matches, but your coefficients are completely different. Okay, so somehow or another, we have to make this equal 30, and we have to make this equal 54. So this we have to make equal 30t.
Multiply it by 3/2.
Well, you kind of ruined the surprise there. I was leading up to it. So in this one, you want to make equal 54, t to the third. Okay, and there's an actual way to do that. We want to know 20 times what will turn that into 30. And we want to know that 36 times what will make that into 54. Okay, so if we divide both sides by 20, y equals 30 over 20, which is 3 over 2. And we divide both of these, y equals 54 over 36. If we divide both of those by 18, it'll be 3 over 2. All right, so we know that 3 over 2 times du is equal to 3 over 2 times 20t plus 36 t to the third. Oh, forgot my dt. And if you actually distribute that 3 over 2, you have 60 over 2, which is 30. Oh, bring that down some. Yep, 60 over 2, which is 30. And 36 times 3 divided by 2 will give you 54. Okay, so that means 3 divided by 2 du actually equals 30t plus 54t to the third with respect to t. So that's why that one's a little bit different. You can't just factor out something by looking at it immediately. You can work your way around it. All right, so if we rewrite it, we have the integral of 30t plus 54t to the third. Like I said, I bring my dt up just so it matches when I replace it. With respect to t, over 10t squared plus 9t to the fourth. we're just going to rewrite that because this is our 3 times 3 over 2 times du. So we can replace all of that with 3 over 2 du over u. Which means we can just factor out that 3 over 2 times the integral of du over u. Okay, so that's going to give us 3 over 2 times the natural log of u plus c. So all we have to do now is replace u.
Question.
Sure.
So, are you supposed to put the parentheses over, is it over plus c as well, or is it just the ln u? Even though it's just c,
Mhm.
would that still multiply by 3 over 2?
Well, you could, and the only reason you don't have to really worry about it is, let's say if you did 3 over 2 times natural log of u plus c, that would just give you 3 over 2 times natural log of u plus 3 over 2 times a constant. So 3 over 2 times a constant is still just a constant. So you still end up with 3 over 2 natural log of u plus c.
Sorry, we have to have this conversation.
Well, sometimes it takes a second time to drill it home.
Because a constant is a number that you don't even know what it is.
Yeah.
You take a number that you don't
So
know
you have
what it is.
10t squared plus 9t to the fourth. And actually that will always be positive, so you don't really need the absolute value, plus c. We'll bring this up a little bit. Oh. All right, so any questions on this one? Like I said, this one's a little bit tricky.
How are you able to do multiply 3 over 2 on both sides? Is that following the constants rule? Like, because you can't just match.
Oh, because all we did was use this one because we figured out our du already.
Mm-hmm.
So here, we already knew that just looking at this didn't match up to that.
Right.
It had the t and it had the t thirds, but that was it.
I get that.
Yep.
I'm just confused how you were able to manipulate it. Because wouldn't that
Mhm.
change the entire.
No, because you.
Oh.
Oh, no,
do
yep,
both
because we did both
Oh,
sides.
both sides.
Yep,
Okay.
that was it.
So, because you do both, because you
Mhm.
can't just do one side.
Yeah,
That
that's
would
what I
change.
was.
Yeah.
Yeah, but.
Yep, so once
no
you do
matter
both
what-
sides, you're good.
Okay.
Yeah.
That makes sense.
That's like dividing, say 3 divided by 3, you know.
All right.
Divided by both sides, okay.
Yeah.
You know, the same thing is, you gotta find a fraction that equals the same denominator. Yeah.
Okay, that makes sense.
All right, so let's do one more of those. But we'll make it a definite integral. So the integral from 1 to 2 of 3x plus 4x to the third divided by 3x squared plus 2x to the fourth with respect to x. And we want the exact answer. So we don't have to worry about decimals and all that stuff. All right, so just like before, our goal is the integral of du over u equals natural log of u plus c. So we're going to let our denominator equal u. So let u equals 3x squared plus 2x to the fourth. Okay, which means our du is equal to 6x plus 8x to the third. which is a little different than what we have, but if we factor out 2, we'll have that one, but I'm going to go through the previous step just for practice. So we can make equal 3x, and this one you want to make equal to 4x to the third. Okay. So just like we did before, yep, you want 6 times some number to equal 3. And you want 8 times some number to equal 4. Okay, so you have y equals 3 over 6, which is 1/2, and y equals 4 over 8, which is 1/2. Okay, so that means you just multiply both sides by 1/2. Or we could have factored out 2 and then just divided both sides by 2, and it was giving us the same thing. Okay, so we have 1/2 times du equals 1/2 times 6x plus 8x to the third. Keep forgetting my dx. There we go. Bring that down a little. And the minute we distribute our 1/2, that gives us 1/2 du equals 3x plus 4x to the third dx, which is what we wanted. Okay, so that means our integral from 1 to 2 of 3x plus 4x to the third, and I'll go ahead and bring my dx up here just to make it all look nice and neat. 3x squared plus 2x to the fourth becomes the integral from 1 to 2 of 1/2 du, or 1/2 times du over u. Factor out that 1/2. We have the integral from 1 to 2. Oh, forgot to put in my 1/2. du over u, which just becomes, I'll put that underneath it, 1/2 times the natural log of the absolute value of u from 1 to 2. So by now you should know what's going there. Replace u before substituting. Place u before you substitute. Okay, so that will become 1/2 times the natural log of 3x squared plus 2x to the fourth from 1 to 2. Okay, so first we plug in the 2. Bring that up a little bit. Okay, so that gives us 1/2 times the natural log of 3 times 2 squared, which is 4, plus 2 times 2 to the fourth is 16. Uh-oh. I'll just go ahead and erase it. There we go. Minus, now we plug in our 1, natural log of 3 times 1 squared, or 3 times 1, plus 2 times 1, which gives us 1/2. Natural log of 32 plus 12 is 44. Minus natural log of 5. Oops. All that wasted space.